This is a word problem that looks much more intimidating than it really is. So gas in the cylinder right here is maintained at a constant temperature T. That's important. You'll see in a minute. The pressure P is related to the volume by this formula right here. And it's telling me A, B, N, and R are constants. So find the rate of change, dP, the pressure, with respect to the volume. So really what I'm finding here is P prime. But I'm in luck because A, B, N, and R, and T are all constants. And those are easy to find derivatives of. So let's kind of work the problem. I'm going to write it down here again so I have a little bit more room to work. So I have pressure is equal to nRT divided by V minus NB minus AN squared over V squared. And my only variable here really is V. Everything else is V. Everything else is a constant. So thinking about my quotient property, I know I'm going to have F times G minus F times G, and that one's going to be prime, and then that one's going to be prime, all over G squared. I'm just going to apply it to each one of these separately. So P prime is equal to, well, nRT prime times V minus NB minus nRT not prime times V minus NB prime divided by V minus NB squared. That is for this piece right there. Let's simplify that one first, and then we'll come back to the other piece. Now let's set up the other piece first. Minus, now I'm going to set up this piece, I'm going to do this piece here in black. So that's going to be, again, I have F prime G minus FG prime. So I'm going to have minus AN squared prime times V squared minus AN squared times V squared prime, all divided by V squared squared. Okay, so let's see if we can't do some simplification now. I'm going to look at my first term right there, the red term. So I have P prime is equal to, well, nRT, nR, and T are all constants. So that's going to be 0 times V minus NB. That'll be easy to simplify. Minus nRT, some kind of a constant, times, well, V minus NB prime, well, V has a power of 1, so that's going to be 1, so V is going to be 1, the derivative of that, and NB is going to be 0, times 1 minus 0. So it's not looking so complicated. And that is still divided by V minus NB squared. Now that is minus, now I'm going to do the derivative of my other piece here. Well, AN squared prime, since A and N are both constants, AN squared prime is 0 times V squared minus an squared times, put a bracket there, well, v squared, the derivative of v squared would be 2v, and that's all divided by v to the fourth. Let's go back to my red piece. So p prime, well, this is 0, so that's going to cancel out. So I'm going to have, well, this is going to be 1. I don't need that 0 there. So I'm going to have negative nRT divided by v minus nb squared. And then let's simplify this black piece. Minus, well, this is going to be 0. That's going to cancel out. So it's going to be negative, well, I can just multiply this so I can move my constant to the front there, 2an squared v over v to the fourth. Well, that's looking pretty good. And the only thing I think I can simplify, and now I'm going to write it in green since I'm getting the green light here, is I have negative nRT divided by v minus nb squared minus, well, I have a single power of v here and a power of v to the fourth there, so it would be minus, but it's a negative and a negative, that makes it a plus 2an squared divided by v cubed. And this is the answer. A little bit tricky, you got to think about what's constant and what's not, but if you just take it one step at a time, do each of your derivatives separately, not that tough of a problem.